How's it going, everybody? And in this video, well, I should say, welcome back to our Cisco Enterprise series for CCNA, CCNP, and CCIE candidates. In the switched campus section of our network infrastructure, we're going to dive into switch campus, but I'm going to do this a little bit out of order. I'm going to start off with Vlan technologies, and we're going to work our way through that. So I'm going to go do a kind of a deep dive into what all this stuff means. So we have like a level set video that sets up our individual section, and then we'll go into individual videos on how to configure those things as we're going along, so that we at least we have a knowledge base of information before we start diving into a particular topic. So we're going to start with VLAN technologies, and then I'll figure out my way from there. So with that being said, let me go ahead and first start off with at least a definition of what each one of these things are, so that we know where we're at. So access ports. What is an access port? So I'll give you a visual representation, and then I will circle back. So if I was to go ahead and get out of the way and bring this guy over here and zoom in just a touch, a little further, a little more, there we go. Okay. So this guy right here, gig 01 and gig 02, these are going to be access ports. And the reason why they're considered access ports is actually very, very simple. And I'm going to go ahead and keep that on the screen so you guys can see what I'm talking about. Let me go ahead and close that out. So I will scoot this, nope, goodbye, scoot over, there we go, perfect. So the reason why we call it an access port is actually very, very simple. It provides access to something. In this particular case, it's going to be a PC. It doesn't have to be a PC. It could be a printer. It could be a phone. It could be an access point. It could be a sensor, depending on the type of environment you're in. I've seen all kinds of other things. I'm trying to think of what else might be attached to an access port. No, you wouldn't throw a server on an access port, at least in the campus, in the LAN. That would be an access port on a server switch. So theoretically speaking, you're still right. It's still going to be an access port. It's going to be a part of that server is going to be plugged into a port that's in a VLAN. Yes, that is still true. But for this particular part of it, that's going to be a PC, right? We're not going to have servers, at least for the most part, in the campus, unless we have a specific reason to, like a branch office or something like that, that might have a server for, read-only domain controller or any number of other things. So that's the first thing that I want to cover. And we're going to go through how that all comes into play. Then we have trunk ports, and we're only going to be dealing with 802.1q trunking encapsulation. So what do I mean by trunking encapsulation? What does that mean? Well, the simple answer to your question is this. So VLANs are something that sit on a switch, and the more VLANs you create, the more, and they need to span more than one switch, you need to have something to interconnect them. So the way that you do that is you use an encapsulation mechanism for this interswitch communication. Simply meaning you use the 802.1q 4-byte header to let the switch that's sending the traffic from, say, switch 6 to switch 5, when switch 6 sends traffic to switch 5, switch 6 has to tell some way, the 802.1q header, switch 5, what information is relevant so that switch 5 knows which VLAN to put that particular traffic inside of which VLAN. So I jumped ahead just a little bit on that, but I'm working my way down the list. So I'm going to jump down. So the 802.1q can either be dynamically or statically set. And we'll take a look at exactly what that looks like when we get into the individual pieces. But the trunking capability comes into play whenever you need to traverse between two switches, or two or more, really. So anytime you see connectivity between two switches, you must have a trunk. There's no exceptions. You must have a trunk. With the exception of VLAN 1. And you might say, well, Rob, you just said no exceptions. I know, I lied. If you don't create any VLANs at all on your switches, and you just let the default VLAN 1, sit on your switches, what will end up happening is PC48 and PC67, they will come online, they'll start sending traffic. Switch 6 will learn that traffic, and because there's a link over to switch 5, and you've got it configured as such, a trunk, and only VLAN 1 is allowed, you don't need to do anything with it. It'll automatically send the traffic across the wire from switch 6 to switch 5, and traffic will be able to pass through because it's VLAN 1. VLAN 1, consider that like the default VLAN. You can't get rid of it, you can't turn it off, you can't delete it, none of that type of stuff. Interestingly enough, Spanning Tree Protocol, CD, and CDP use VLAN 1 for control plane replication, propagation, synchronization, all that type of stuff. So you need something inside the network to allow Spanning Tree and CDP to talk. Now, do you need CDP? You don't. Cisco Discovery Protocol. We'll talk about that later. But Spanning Tree is going to be there one way or the other. It's always there. Now, here's an interesting factoid about Spanning Tree that I learned a long, long time ago. So, Spanning Tree's job is to limit the broadcast domain of a particular VLAN to try to prevent there from being layer 2 loops. So, if you accidentally plug port 1 on switch 1 into port 10 on switch 1, that would be considered a loop because you are going to be sending traffic back to yourself. Now, in the case of something like this right here, where you have switch 2 and switch 1, notice how I've got gig 01 and gig 01, and I've got gig 00 and gig 00 plugged in here. That would also be a loop. Now, it's a self-inflicted loop, but it's very, very easy to get around that. So, in situations like that, you would need something in place. Spanning Tree Protocol is what's used to block that. One of these interfaces on these switches would get blocked from sending traffic so that there is no loop. Now that I've talked about that, let's circle back to a VLAN. What is a VLAN? A VLAN stands for a virtual local area network. It is a very early adoption to virtualization of network hardware. A VLAN is a layer 2 broadcast domain. That is analogous, the same exact thing at the layer 2 level, that a VRF, a virtual routing and forwarding instance, is at layer 3. A VLAN sits on a switch, where a VRF sits on a router. That's the easiest correlation I can give you. However, you can put VRFs on a switch. Go figure. Now, when we talk about this in more detail, the key capability here is the VLAN is what allows you to logically separate a switch into multiple switches. Okay, logically separate a switch into multiple switches. How do you accomplish that? Well, you accomplish that by creating multiple VLANs on the switch and then placing placing specific ports into that VLAN. Remember we were talking about access ports just a moment ago? Well, you place those access ports into those VLANs so that they can learn about traffic from the ports that are connected to those devices. In other words, if I want PC48 and PC67 to be able to talk to each other, I have to create a VLAN first. Then I have to go to the interface that VLAN is supposed to belong to, or I should say, it's the other way around actually. Create the VLAN first and then go to the interface level and then put that port into that VLAN. That's how it's supposed to be set up. Once you've done that, and you've done that for 2 or more interfaces, PC48 and PC67 will be able to talk to each other. Once they start talking to each other, then you'll be able to start building the MAC address table for VLAN X, Y, Z, whatever it might be. In this case here, I've got VLAN 310. I've actually recorded a video for this little section already and gone into some details to what this is here, so that video is coming up actually after this one. But anyway, not very relevant at the moment. So these 2 PCs are actually up and running, and so is the switch. The switch is actually configured with a handful of VLANs. What's cool about VLANs is once you understand that they can logically separate a switch up to a 48 port switch, you can break down that switch into multiple logical switches. So if you're familiar with virtualization on the virtual machine side of the house, meaning You can download and install VMware ESXi onto a server, and you can run multiple virtual machines on that server. You're logically doing the exact same thing on a switch with VLANs. You are logically separating the individual switch ports into their own VLANs. Now, the question that I get quite a bit at the entry level is, okay, how, if I have, let's say I have a 48 port switch. The first 12 ports are in VLAN 10. The next 12, 13 through 23, or 24, excuse me, are in VLAN 20. Can they talk to each other? The answer is no. Not out of the gate, they won't be able to. Why not? Well, because they are logically separated based off of VLAN. So the easiest way that I can describe this is this. The moment you start using a VLAN to segment traffic, and you create the VLAN and you apply it to a specific amount of ports on that switch, and you plug devices into other switch ports that are not part of that VLAN, you have now logically separated that switch into two logical switches. The only way to be able to get the ports that are in, say, VLAN 1 to be able to talk to the ports that are in VLAN 10 is to route them between the VLANs. Now, we haven't talked about layer 3 networking yet, but we will. And essentially what you get with that is you'll either need, on this switch here, you'll need to either create an interface VLAN, so give that VLAN a gateway so the traffic inside that VLAN can leave it and come back into it. Or you need to do what we're going to do in this particular site. Let me go ahead and scoot this over just a little bit. R24 and R23 are going to be router on a stick. So we're going to virtualize again the gigabit interface on R22 and R23 and R24 to allow multiple VLANs to be able to talk to each other by way of these individual routers. And I'll talk more about router on a stick when we get into how that whole process works, but there's a whole piece to that. Layer 3 routing, we have a whole bunch of layer 3 stuff to go through. So don't you worry or fret or worry about any of that type of stuff. We're definitely going to dive into how that all that type of stuff works. So that's essentially what that does. Now there's multiple ways of controlling VLANs. There's a couple different ranges of VLANs. So let me go ahead and pull my pen tool out real quick, and then I'll do a little bit of whiteboarding here to try to help you guys understand this. All right, let me go ahead and pull out my pen tool. Let's go medium thickness, and we're going to use, blue. Blue should work, right? I'm not a big fan of that. Let me change this color over to be, we'll just go black. Black always seems to work. Okay, so we've already talked about access ports, right? We've talked a little bit about 802.1q trunking. This one's going to be a little bit more challenging until you actually see it in person or in play. So let's talk about the VLAN ranges first. So we'll go VLAN range, we'll talk about the native VLAN, the voice VLAN, and then pruning. Because pruning kind of ties into trunking a little bit. So we'll dive into those details first. So you have a normal range and extended range VLANs. So the normal range is going to be, so I'll put here, up here on the top here, I'll put N equals 1 through 1001, because 2, 3, 4, and 5, 1002, 3, 4, and 5 are reserved for old school VLANs that nobody uses anymore. Then you have the extended range. It's going to be 1006 through 4094, I think it is. You can go up to 4096, but 4094. The question I get every once in a while is, can I actually use 4,000 VLANs on the switch? No, you can't. There's no switching platform that I'm familiar with that has the hardware resources and the memory to allow you to create 4,000 different broadcast domains. The only reason, so it's not so much the amount of VLANs that you can create. That's not the use case that we're trying to go for. If you really wanted to go super duper high-end VLAN numbers, there are some ways that you can make that happen. I'm not going to get into those right now, but no environment that I've ever worked in, except for a couple of specific use cases, ever went beyond 10, 15 VLANs. There were a couple of specific ones where I had a couple hundred in a site, and it was just a bloody nightmare to try to keep that environment from staying operational and not have it go belly up from one moment to the next. But anyway, I digress. So those are your VLAN ranges. Is one through 1001 and 1006 through 48094. Now you have the VLAN numbers are there, the range, because this is a 12-bit value, right? You have 12 bits make up your VLAN range, minus the 4 in the middle that you can't use. If you decide to go and use your extended range, that's great. And I'm 99% sure in order for you to, I'd have to go back and double check, is most customers that I work with, they don't use the extended range VLANs. Because most customers are able to get away with a normal range because they've already got 1,000 to play with. I've never walked into an environment that's had more than 250 or 300, except for one specific use case, and most customers were under 30 for the most part. So you've got a number of VLANs that you can leverage. So that's really the point that I'm trying to convey here, is that if you need to create a bunch of VLANs, you can do that. And usually what customers will try to do, which is kind of makes sense, but still at the same point in time doesn't, is they try to associate VLAN IDs to a site. So let's say, for example, you have 20 locations. I have seen customers go and try to do it based off of location number. You've got, 1, 2, 3, 4, so they use, 1 through 10, and then they use, 21 through 29, and then they use 31 through 39, so on and so forth, right? They try to associate it that way. And yes, it sort of works from a nomenclature perspective, but the reality of it is, the VLAN, again, you got to remember the VLAN itself, the core capability of what a VLAN does is it's a logical breakup of a switch. That's its job. So what's cool about that is I can, on a per switch basis, and for example, if I'm down here, let me go switch colors real quick to, let's go to yellow green. If I'm down here at this location, and I'm using this subnet range, the 172.31.0 through 5. That's the VLAN, the subnet ranges I'm using here. And then I want to come up here and use 172.31. I want to start off at, say, 8 and go to 10. Let's say that's the VLAN range I'm going to use over here is 8, 9, and 10. Or the subnet range, excuse me. The question that I have for you guys is this. Can I reuse the VLAN IDs that are at this site up here? The answer is yes, I can. Well, hold. How do you do that? How do you not break the network? Well, simple. VLANs are a broadcast domain, right? I'm not trying to connect this switch to this switch, right? I'm not doing that with the trunk. And if I did need to do something like that, I would definitely not be using a very, very long SFP single mode fiber to do that. Like, I would be the laughing stock of the networking industry if I was to go out online and say, yes, this is a great idea. No, don't do that. There are multiple ways to get that job done, and none of them involve you running an SFP, a fiber circuit between the two. So no, you don't do that. The reason why you can utilize multiple VLAN IDs in multiple locations, or the same VLAN ID or ID range in multiple locations, is because the subnets are going to change, because they're a broadcast domain. So I'm going to break the rules of teaching CCNA here for a second and say most people equate a VLAN ID to a subnet to a broadcast domain. In other words, you associate a VLAN ID to a subnet, that becomes its broadcast domain. You don't reutilize that same VLAN ID elsewhere, and you don't commingle multiple subnets inside of the same VLAN. In other words, I can create VLAN 10, and I can put 10.1.10.0/24 in that VLAN. Guess what? Guess what I can also do? I can put .11 and .12 and .13 I can put as many VLAN or as many subnets, IP ranges as I want into a single VLAN. How is that possible? Again, very, very simple. Because it's just a broadcast domain. It's there to learn MAC addresses. So for every VLAN you create, you end up creating a spanning tree instance and a MAC table for MAC address learning. Whenever you create a VLAN, you're creating a spanning tree instance and a MAC address table at the exact same time. You don't have to do anything. It automatically happens in the background. What's cool about that is I don't recommend you doing this. This is bad juju, right? You're asking for problems if you're doing this. Again, use case specific customer that I used to work with did not really understand networking. They just kind of threw whatever they could at the CLI. If it didn't break something or they didn't get like a kickback from the CLI, it's stuck. I could go on for days on that one. But my point is, you can create a single VLAN, and then you can put multiple subnets inside of it. Do I suggest you do that? Absolutely not. Good networking behavior, what's the word I'm looking for? Good etiquette, good networking etiquette is you put some homework into your design. Meaning, you're going to create VLANs, and you're going to have subnets. You're going to have two different spreadsheets, and your two different ways of tracking that, probably a spreadsheet. But you're not going to attempt to commingle anything. You're not going to try to put multiple subnets inside of a single VLAN. It's not a good idea. Is it possible? Yes. So I'm taking the CCIE level knowledge and I'm bringing it down to the CCNA level, saying yes, it is possible. Is it a good idea? Absolutely not. There are specific use cases where it could come into play, but for the sake of argument, I'm not going to bring those up. And if you put a comment down below and go, what are those use cases for multiple subnets in a single VLAN? I am going to politely tell you to don't be dumb. Simple as that. There's really no good use case for that I would come up with. There are use cases, but none of them are good. I'll leave it at that. So now that we have that understanding, right? So I'm going to go ahead and clear the screen off. What I would do, and just to answer the question I asked you guys a minute ago, what would you do? Well, what I would do is you could reutilize these VLAN IDs right here as many times as you want, as long as you associate a different subnet to them. So if we're up here using 172.30.10.0, and I decide to use VLAN, say I use 310 here and 311. Let's see, those are the VLAN IDs I choose to use over in this site. Okay, cool. I use them again. So then I just make my subnet, 172, or it could be 10.1.10.0, right? It doesn't matter. The VLAN ID is locally significant to the switch until you start needing to communicate with other switches. That's the key caveat here. You can have the same VLAN. The VLAN ID is unique to the switch until you need to interconnect switches inside the same VLAN. The moment you need to do that, you automatically have to leverage trunking in order to do that. And then VLAN ID 310 needs to exist everywhere. Right? 310's got to belong everywhere. If you wanted to, and here's another thing that's interesting about VLANs and the whole spanning tree and MAC address table. The moment you create a VLAN on multiple switches, and then you trunk between them, let's just do trunks there. So our traffic pattern will be this for traffic between switch 3 and switch 4 is, let's say this guy right here, his MAC address is A1, because he's just a really cool computer. Well, guess what? A1 is going to be learned here, 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 and here. Why is that? Well, every switch needs to know how to get to that MAC address. Because at layer 2 networking, that is how layer 2 networking works. It's all MAC address based. So you need to propagate your layer 2 information, your burned in address, to every other switch so that those switches know where to send the traffic. So I liken this to layer 2 routing. Hold on, Rob. What do you mean layer 2 routing? I thought layer 3 routing. You're right. It is layer 3 routing. But there's still a lookup, right? The MAC address table, which is what you are going to use in order to keep track of what's going on at layer 2, operates very similarly to the layer 3 routing table. Instead of MAC addresses or instead of IP addresses from the routing table, you use MAC addresses. That is your destination-based information. Pardon me. So how does that come into play? Well, very simple, actually. So what I would do is, let's say I'm learning this on gig 2, this is gig 1, this is gig 0. So what I would do is we'll walk ourselves through how the MAC address table would get built. So I'm on switch 4. So on switch 4, I'm going to learn A1 on port 2. So 0/2. Now I'm going to propagate that on to switch 2. Switch 2 is going to know how to get to A1 via gig 0 slash, or sorry, let's do this one. A1 via gig 0/0. Switch 1 will know how to get to A1 via 0/0 and 0/1. Let's assume that we haven't done any network optimizations like port channels between switch 2 and switch 1. And then on switch 3, in order to reach A1, we're going to use gig 0/0. So what will end up happening is if PC40, which is A4, wants to communicate with PC20, which is A1, how would switch 3, when it receives the traffic, how would it know to forward it? Well, the simple answer is it would look at its MAC address table and go, okay, in order to get to A1, I need to send my traffic out gig 0/0, because I know A1 is not locally connected to me. It was learned in on gig 0/0. Gig 0/0 is a trunk link. So I'm going to send that traffic this way. Now switch 1 receives that and does a lookup and knows that A1 is on gig 0/0 and gig 0/1. So it sends the traffic this way. Switch 2 receives it and goes, okay, well, I know it's on gig 0/0, so I'm going to send the traffic this way. And then switch 4 gets it and goes, oh, well, it's attached to me on gig 0/2. I'm going to send it out gig 0/2 to PC20. That is exactly the same concept as layer 3 routing, except we're using MAC address table. The MAC address instead of the IP address. So we'll circle back to that when we get into routing and how the routing lookup process works and how the routing table controls the forwarding table and all the good stuff that goes along with that, and understanding control plane versus forwarding plane. So hopefully that all makes sense. So that is how that process would come into play. Now that's MAC address table management, but it's still needed to be understood. Okay? Now that we've talked about that and we've understood, so I'm going to come back over here to black. So we've covered, let me go ahead and clear the screen while we're at it. So we've covered access ports, we've covered trunking, we've covered the normal extended range VLANs, and also how the MAC address table is basically used to figure out where a destination MAC address lives in a layer 2 environment and how to get there. Fairly straightforward stuff. Now, the next thing we want to talk about is going to be the voice VLAN, because that is the next most common VLAN, not ID, VLAN type that you're going to run into. So what is the voice VLAN? Why do I care? So if you have an IP phone attached to your network at any point in time, so I'm just going to draw, I'm a horrible artist, so just bear with me here. So if I have a switch, right, I have my switch, and then down here I have a phone. So I'm just going to draw a link here in this, and then that's going to be my phone. I know it's horrible. I'm not an artist. And then from here, it goes to a PC. So we have PC. Well, what's going to end up happening is you're going to actually utilize two different VLAN IDs. You're going to have the voice VLAN. Let's say the voice VLAN here, I'm going to use the one on the right. So let's say I apply 310 for my data, and I apply 313 for my voice. So this is going to be data, and this is going to be voice. What I would do is I would type in the command switch port voice VLAN 313. Now what's going to end up happening is this phone is getting power, PoE, via this network adapter, this network connection, this Ethernet cable from the switch. The switch is PoE enabled. So it provides the power to the phone boots up. When the phone boots up, it's going to get some information through DHCP that's going to point it to Call Manager or some server that it's going to be able to download its configuration file from and then register to Call Manager. I'm going to say Call Manager because I'm familiar with it. And then once it registers to Call Manager, it'll be able to start sending and receiving phone calls. Well, in order for all of that to happen, you need to have a voice VLAN applied to your port in order for that to work. If you don't apply the voice VLAN and you have a voice-enabled network with IP phones, whether it's Cisco, Avaya, 3Com, or any other, insert your voice product into the sentence, you're going to need some way to differentiate that traffic. Now, the question I get a lot is, does this interface right here, does this guy need to be a trunk interface because I'm dealing with two VLANs? And the answer to that question is no. It should not be a trunk unless you're connecting it downstream to another switch, or you're connecting it to an ESXi or some sort of virtualization server, and you are trunking multiple VLANs down to that server. And then the server, on the ESXi side, on the vSwitch, you'll create port groups with different VLAN IDs. Other than that, you don't need a trunk going down to a phone or a PC. You don't need that. Now, the phone will pass the data traffic on VLAN 310 because there's information inside of the payload. So what ends up happening is you have this sub-protocol 802.1p. So 802.1p that comes into play that is going to be used by the phone to send information to the switch so that the switch knows which VLAN to leverage in order for that phone to communicate. So it's actually referred to as an internal VLAN. You can't configure this. I think it's VLAN 0 if I'm not mistaken, but not relevant to our conversation. So if you want to know more about that, go look up the voice VLAN capability on most modern Cisco Catalyst switches, whether it's the 9K or if you're on older platforms, the Cat 3K, that'll be your switch platform you'll be using. So that's how that comes into play. So that's essentially what you would need to do there. So you're going to be using the command switch port access VLAN 310 for data and switch port voice VLAN 313 for voice, or whatever VLAN ID is used for that particular data type. Hopefully that makes sense. So we've covered that. We've covered the voice VLAN. We have two left. We have native VLAN and we have VLAN pruning. So let's talk about, let me go ahead and clear this off real quick so we can talk about the native VLAN. The native VLAN is kind of cool, actually. It's one of those things where you don't see it used very often. At least I don't see it used very often. What is the native VLAN? The native VLAN, native equals untagged. So when I say untagged, meaning there is no 802.1q value. It's all zeros. So when I say that, not VLAN ID 0, just 0. So when I say native, you are untagging the traffic. It still gets a tag, right? It still has an 802.1q header. It has to when you're going back and forth between a pair of switches. You still have to have a tag. It just doesn't give it a numeric value inside of the 802.1q header. That's what I want to. That's what I'm trying to convey. Is there's no numeric value to indicate VLAN 1, 10, 20, 72, whatever. And I should be able to do a packet capture between these switches, so you'll be able to see the actual traffic going back and forth. Hopefully that'll work. But that's the game plan. So native means it's just untagged. So here's the kicker. If both sides of the trunk need to agree on the VLAN, on the native VLAN. So if I'm sitting here between switch 1 and switch 2, and I have a link between the two, and this guy here is a trunk, whatever native VLAN you choose to use, and so the other question I get a lot is, why would I use a native VLAN? The answer to that question is, it depends. If you have a reason to change it, change it. Sometimes, the very few times that I've seen people do this is usually for management, and they want management traffic to be untagged for whatever reason. Now, here's the interesting thing about that. At a larger location, like a main office, a medium-sized office, somewhere where you could leverage what they refer to as out-of-band management, a lot of your newer model switches today come with a dedicated RJ45 management interface. So they're usually coupled together. You'll have like a rectangle around it. You'll have an RJ45 jack here, right? And you'll have the little link lights here, and then you'll plug it in here, and then you'll have another one down here, just like this. And they'll both be inside the same block. They'll both be labeled management. The interesting thing about this is one will have probably some blue around it for the console cable. This one will be here for IP, meaning you would plug in the console cable to this port, and then on this port you'd plug an Ethernet jack into this one and connect that to the rest of the network. So in the event that you needed to connect to this switch, but you're not physically there, you're coming into an out of band, meaning that you're not coming through the data plane of the switch through all the other connections. So think of it like you have a connection coming into this switch right here, that's the management 0 interface on that particular switch. Your newer model Cat 3Ks can do this, so can the 9Ks, stuff like that. If you're at a branch location where you might only have one switch, it's not that feasible to do that. A lot of customers will opt to just use like an SVI as the management network. They'll have a small /29 or some sort of, or /24, whatever they choose to use. They'll leverage that and then come in band. So over the data plane that everything else comes in over, they'll manage the network in band where they have to, but they'll leverage out of band management where they can. So it really depends on the situation at hand. So just remember, the key thing I want you to remember about native is untagged. So are there good use cases for that? Some, but it really depends on the scenario at hand. And I honestly don't like using them. I don't think the native VLAN is a good idea for the simple fact that if you start using them and you don't really fully understand their use case or whatever the case might be, I'm not a big fan of them. So now we've covered native VLAN. Let me go ahead and clear the screen off again real quick, and we'll talk about manual VLAN pruning and what exactly that means. So why would I care? Why would I want to manually prune VLANs? So what would the use case for that be? So manually pruning VLANs is actually very it makes a lot of sense if you understand what you're trying to do. Let's say for example you've got switch 1, you've got switch 2, and you have switch 3, and you got connections coming down to both of these. Now on switch 3 you've got VLANs, let's say 21, 25, and 26. But up here on switch 1, you've got 10 through 30. And down here, you've got 10 through 30. So in this particular case, Well, what's going to end up happening? Well, if you're leveraging something like Vlan trunking protocol, VTP, and this is a server, and this is a client, what will end up happening is switch 3, even though it only has ports inside of VLANs 21, 25, and 26, switch 3 will learn VLANs 10 through 30, and then any MAC addresses that are in VLANs 10 through 30. So let's say, for example, there's 200 here, and there's 200 here. Well, guess what? Switch 3 is going to have 200 MAC addresses on it too. But reality is, let's say there's 10 ports in port 25, 5 in 25, and 2 in 26. So it's 10, 15, 17. You really only need 7. You're going to learn 17 MAC addresses. So let's say it's a 24 port switch, right? You don't have a whole lot going on there, so you've appropriately sized it. But it's got 20 VLANs on it, and it's learning 200 MAC addresses. That's not like overkill or completely obscene, but it could be much, much worse. So what manual VLAN pruning does is you can go to, and I'm not a fan of VTP either. VTP, we're going to talk about it, but I am not a fan of using it. I'm very much a fan of transparent mode. So remember that for VTP. We'll talk about VTP coming up. But if you've got VTP servers and a VTP client, if you create a VLAN, you create, modify, or create, edit, or delete a VLAN, that information is automatically propagated down to the downstream switch, which is your client. Now, in the case of transparent, it doesn't pay attention to it, which is why I like it. So if I've got VLANs 10 through 30, what I can do is I can come down here. Let's say I move away from server and client, and I put transparent everywhere, which is the way it should be in my opinion, but that's just my case. We'll talk about both ways so you guys have a clear understanding of how it works. What'll end up happening is I will go in and I will remove all VLANs except for 21, 25, and 26. And then what I will do is on this side here, I will create a trunk allowed list for brevity. I'm going to only put AL. And what I will do is I will say 21, 25 through 26. Those are the only VLANs that are allowed to go down this trunk link here and this trunk link here. And that is configured upstream from the affected switch. So all of your distribution switches, so if I wanted to control switch 4 and switch 3, I would configure trunk allowed lists on every one of these interfaces here. And let me actually recoil that a little bit and change to a different color so it's easier for you guys to see. So if I wanted to control these two switches, I would put trunk allowed lists here, put an allowed list here, an allowed list here, and an allowed list here. That would only allow specific MAC addresses to go across the VLAN in that particular VLAN, to particular MAC addresses to be learned in that VLAN. And only that information would be sent downstream to the switch that actually needs it. And that, ladies and gentlemen, is how a manual VLAN pruning works. Fairly straightforward concept, but it's something that you really should understand and really should dig into in case you're interested in knowing more about how that works. It's kind of a game changer in my opinion. So if you're struggling with that, or if you're struggling with MAC address propagation and something along those lines, or high CPU, if you have a lot of VLANs, I definitely think a trunk allowed list would be your best bet. So that is that. I was actually going to go a little bit deeper and talk a little bit about how you can how there's other technologies out there that can help with that, but that'll be for a video for a different time. So hopefully that all made sense and you understand it. And this is how I'm going to go through. I'm going to explain the individual concepts in a holistic video, and then I'll go into more depth in individual videos, give you more of a high level, and then so you know what you're walking into when you first dig into it. So in the next video, what we're going to go do is I'm going to go ahead and bring switch 5 online. And then once switch 5 is up and running, and that one's good to go, so let's come over here, yellow, green. I'm going to bring this guy online, and then once he's online, we're going to configure a trunk link right here. And then that trunk link, I'm going to create these VLANs on this switch, and then that will allow switch 5 to begin learning about these two MAC addresses right here from PC48 and PC67 and be able to do its job. So switch 5 will start learning that traffic and all the good stuff that goes along with that. So fairly straightforward stuff. And then for things like the native VLAN, the voice VLAN, or technically speaking, access ports, voice VLAN, and normal range VLANs have already been covered in the video, which would technically be the next one after this one, but the one after that would technically be the trunking video. I'm not going to do any native VLAN or I could do the native VLAN, but I'm actually going to do that on this other location up here. I'm going to start doing like manual VLAN pruning just so you guys can see the difference between the two and how that would come into play. We're also going to talk about VTP since we're here, and we're talking about VLAN propagation. That is a concept that I don't see on the blueprint. However, I am not going to they don't have it on the blueprint here. I don't even think they have it on this guy. Let me go clear the screen off real quick. I don't even think they have it here. Nope, I don't see VTP. Like VTP's not taught anymore, maybe? I don't know. Encore, is there anything for VTP here? Virtualization, infrastructure. Yeah, they don't even talk about it anymore. VTP is like a thing of the past. Interesting. Well, I'm going to talk about it anyway because it's on the switches. And if you don't know what it is, I'm going to cover it anyway. Same thing with I'm going to cover RIP version 2 because it's out there. And VTP is still widely deployed. A lot of customers still use it. I don't agree with it, but you know what? It's not my game. It's it's not my show. Other people want to do what they want to do. I'm just knowledgeable of what it is. That's the best I can do as an engineer. So hopefully that answers all your questions. If you have any questions about anything that I've talked about in this video, feel free to drop a comment in the comment section below. It doesn't even need to be it could be a question, it could be feedback, whatever you want to do. It's up to you and how you want to handle that. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you fine people in the next video.